So we have here a circuit with just one battery. This compensates for the three batteries in parallel, and with R over 3 internal resistance. This is for the battery equivalent for the three, because each one of them has R. So as the three R's are in parallel, total or equivalent of them is R over 3. This is connected to R capital. Okay, so eta equals IR over 3 plus IR, which equals taking a common factor, we can simply add R over 3 plus R as follows. We can make this as 3R capital over 3, and hence we can rearrange for I, okay, as 3 eta, okay, over R plus 3R, and as we want potential difference across the resistor R here, we will just multiply this by R capital. This is shown here. Okay. We first need to remember the relation periodic time equal to by m over k. So f equals 1 over 2 pi square root over of k over m, the inverse. Here is f inversely proportional to square root of mass. So f2 over f1 equals root of m1 over root m2, which equals 1, or you can say it as root m1, and root m2 is 1.21 m1. Okay, this is the same as root 1.21 times root m1, and a root m1 can be eliminated with root m1, so we have this ratio to be equal to 1 over root 1.21, and for so f2 equal f1. We need here to clarify why we write m2 to be 1.21, because there is an increase by 21%. So it is 100% for the value to be equal, okay, and 21 to be more than equal by 21, same as 1.21. If you divide the 121 over 100, it will give you this number, which I wrote here. Okay, I divide here, I mean to divide and just to find the ratio between the final number after increase and the equal number of 100. So we have t here equals to 0.4 second this is the one oscillation is completed in time of, this is the periodic time. We have the frequency is the inverse of 0.4, which is 2.5 second minus 1. We have lambda to be equal to V over F. To get V here, we have length over of 4 meter, and we have compression takes 2 seconds to travel the complete length of the string. Okay, so compression or rarefaction, or if it is a transverse wave, peak or trough, any part on the wave cuts the same part as the same distance as the other part. So if we have compression cut 4 meter in 2 seconds, we have rarefaction, we have any point in the wave, so it is the speed of the wave 4 over 2. This is divided by 2.5, and we have here the answer as 0.8. Okay. Certainly, it is directing laser so that patterns are produced at eye level, something risky. Okay. Must be coherent with each other. So we should remember how we get the relation L lambda equal d sine theta. It was equating the path difference between two rays to N lambda, and this path difference is this distance here. So it was this angle theta, and to get this distance in terms of theta by trigonometry, sine theta equals the path difference delta over the hypotenuse here, which is the distance between the two slits, which is d. So path difference equal d sine theta, and for condition of constructive interference, we have delta should equal to n lambda, destructive should equal to n plus half lambda, and for analogy here, we need angle theta to be as phi, and we will choose between distance equal to lambda either to be g, okay, or to be h. If we saw the question carefully, we will find that it asks about first order maximum, which means n equals 1. So lambda here is equal to d sine phi, which again is the bus difference, which is g. Okay, so I would accept that lambda equals to h sine phi, or this is same as g. Okay, What is not a possible consequence of electrons hitting the target X-ray can be produced photoelectrons. This cannot be produced because it's not produced by electrons hitting uh, the target, it's produced by photons hitting a metal. Okay, we can't choose infrared because its energy is weak to ionize the atom, and certainly not the microwave. It follows the infrared on the AM spectrum in direction of increasing wavelengths or decreasing frequency energy. Neutrino is um, not charged. This is first, and cannot make an ionization. So we have that HF equals phi plus Vs. This is the work function. This is the stopping potential need to overcome the kinetic energy of the electron to stop them. So it represents the kinetic energy with which the electrons are released after HF enables them to overcome phi. So for same metal plate, we have phi is a constant, okay? And as the stopping potential is not changed, we have Vs also as a constant, and we use a different source L2, but as both Vs and phi constant, we expect F to be constant. So the other source differs in rate of emission. This means that its intensity is different, not the frequency. The frequency from this equation is proven to be constant, but as we know that power or intensity is just power over area, so let us talk about power is fine too. It equals the energy of the photon times the number of photon over time for same time. If we have same F, so this means that N for the L2 is greater than for L1, or as it doubles here. Okay, this means it doubles and the frequency is the same. So answer is A. Okay, photoelectric demonstrates wave-like behavior of electrons. It is of photons, not electrons. Demonstrate wave-like behavior of light. This correct. Diffraction demonstrates wave, not particle. And diffraction demonstrates wave, but of electrons. What an easy question.